Periodic Trends by Emily Caterly.
Let's start with Coulombic attraction. Coulombic attraction is the attraction between positive and negatively charged particles. Moving right across a period, the attraction increases. This is because within a period, all of the elements have the same number of energy levels, but an increasing number of protons. With more protons, they attract electrons closer. However, going down a group, the attraction decreases because although there are protons being added, there are also energy levels being added, so electrons get farther away from the protons. Next is ionization energy, which is the amount of energy required for an atom to give up an electron. If going across a period, elements have more attraction for their electrons, then it will take an increasing amount of energy to remove an electron. Likewise, there is less attraction going down a group, so the ionization energy will also decrease.
Here we have Jessica and Larry. Jessica says, "You can't take my electrons. We are perfectly happy together and they complete me. If you take any, then everything will be off." She says this because she has a full octet, which means she wants to hold on to all of her electrons. This also means that she has very low ionization energy. Larry, on the other hand, says, I don't really care. Take some or leave some, or maybe we can share. He says this because he wants to fulfill his octet. And the easiest way for him to do that would be to get rid of one of his electrons to fill up the first electron energy level. While this might not be an octet, he's filling his highest energy level because the first energy level can only hold 2 electrons.
Since he's only getting rid of 1 electron, it requires hardly any ionization energy. Now we have electronegativity, which is how well atoms can attract bonding electrons to themselves. If you recall from Coulombic attraction, the attraction should increase across and decrease down. Well, so does electronegativity. The noble gases are the only elements excluded from this rule because they are not electronegative at all, because they have full octets. Or the most outer energy levels are full, so they can't attract any more electrons.
Here to help us with electronegativity is Carl. He's pretty stressed out, as you can tell. This is because he almost has a full octet, but not quite. He needs 1 more electron to fulfill his octet, which is why he says, "I just need 1 more electron, share with me." Knowing that electronegativity is the ability for atoms to attract bonding electrons, we know that he has a pretty high electronegativity. Carl is going to be right in here because he only needs 1 more. However, noble gases have 0 electronegativity. This is because they have full octets by themselves without reacting or ionizing. So their electronegativity, or their ability to attract bonding electrons, is 0.
The atomic radii of atoms are also based on the attraction rule. The atomic radius of an atom is the distance from the nucleus to the outermost or valence electron. Since we know that across a period the attraction is greater, we should assume that the attraction causes the electrons to be pulled closer to the nucleus. This is true. So if the attraction increases across a period, then the radius will be smaller. And since the attraction decreases down a group, the electrons will not be as close to the nucleus, and therefore the radius will be larger.
Let's suppose you're a kid in a candy store. Your name is Jimmy. You come to the candy store with $1. Therefore, you can only buy 1 candy bar. The next day you come back into the candy store, but today you have $2. So you can buy 2 candy bars. This is similar to how when you move across a period, on the periodic table. As you move right across a periodic table, every time you move right, you increase protons and electrons. Just like you increase one candy bar for every dollar bill. With each increase in protons and electrons, as long as you stay in the same period on the periodic table, the atomic radius decreases because the electrons are pulled closer to the nucleus. Say, Jimmy, you come back the next day after getting paid. You have a bunch of money, and you trade all your money for candy bars. But you don't have any pockets because you're a stick figure walking into the candy store without any clothes on, so you have to hold them really tight to your body. Just like how when we move down a group on the periodic table, we are increasing protons and electrons. This also shows how when you move right across a period, the radius will shrink. This is because as you keep going along and getting more candy bars, you want to pull them close to you so your best friend Timmy doesn't steal them from you. But when Timmy goes to the candy store, his first day to the candy store, he already has a bunch of money. So what's he do? He buys a bunch of candy bars right away. And what does he do with them? He puts them in his hoodie because he wears clothes to the store. So he has a pocket there, and a pocket there, and even though he's not wearing pants, he still has pockets, so it's okay. And he puts it in his hand, and there, and he's not afraid of you stealing them because you're his good friend and you're not going to steal candy bars out of his pocket. So, Timmy is gaining money in candy bars. Or if Timmy is an element, then he's coming with pockets, which means he's going down the periodic table. You, Jimmy, come to the store with no pockets. You are here. You have nowhere to put them but your hands, so you have to hold them close to your body and closer as you get more candy bars, so you move this way. But when Timmy comes to the store, he has all his pockets, so he can put them in other places where he doesn't have to hold on to them as tightly. He's not super worried about them, so he's going to increase down this way. Even though you're both getting more electrons, or candy bars in this case, he has more storage for them, so he's going to be down here while you're up here.
Electron shielding has nothing to do with attraction. So if you're getting tired of me saying the word attraction, then this one is for you. Electron shielding refers to the number of energy levels in an atom's electron cloud. The number of energy levels stays the same across the period, so the electron shielding is the same all the way across. However, when moving down a group, there is an increase in energy levels, so the electron shielding increases.
Captain America here has this shield, but it only has a couple rings on it, so it doesn't shield him very well. When he gets a new shield with more rings, it can protect him better than his old one. So he likes his new one. This is similar to when you go down the periodic table, you increase the number of energy levels. So each time you increase an energy level, the nucleus is shielded by these electrons more. So you could say that the nucleus is more protected than if it were only to have a couple rings. We know that the atomic radius increases going down because as you move down a group, there is an increase in energy levels. These energy levels protect the nucleus because the more levels you have, the further away the valence electrons are. So the radius is bigger and the shield is bigger. Going across a period, however, the electron shielding does not change. Even though there is an increase in the number of electrons from left to right, there is not a change in the number of energy levels.
And that is the basis of periodic trends. May Walter White be with you.